In this example, I'm asked to write the equation of a circle when I know where the center of the circle is, and I know a point somewhere on the circle. And so to do this, let's go ahead and start with the center. The center of our circle, if you watched our last video, is going to give you the h and k values for your equation. And so actually I can write a good chunk of this equation with very little work, I guess. And so using the h and k values to find the center, I'm going to start with x minus 1. Since my h value is a positive 1, my parentheses will have an x minus 1 in them. So x minus 1 squared. Circles are always have a plus sign in between them. My second set of parentheses then will have the y, and again I'll change the sign of my k value, so I'll have y minus 4 squared. And then all that's left then is to find out what the radius, or really specifically what the radius squared is going to be to fill out that last blank. And so to do this, I'm going to need to use that second coordinate. Now what I like to do to answer these questions is to use a graph and make a quick sketch of what's going on. You don't have to graph these, but I find it to be very easy to do with a graph. So let's go ahead and plot the points, 1, 4. Which would represent the center of my circle. And then the point somewhere on the circle is the point 2, and then negative 5. So 1, 2, 3, 4, 5. So right down there. So I have a very long radius, it looks like. And actually I'm going to go ahead and draw in the radius. Let's see how I do here on my iPad. So there, not so straight, but there is the radius of my circle. Now, I didn't draw the full circle in, but remember this was the center right there. So the circle would look something very sloppy, but something terrible. But something like that is what my circle would look like. So anyways, here's the reason that I like to draw out the picture. I need to find the length of that diagonal segment. And so what I can do, I can't count diagonally, but I can count vertically. And I can count horizontally. And so you'll see what we did is we turned that into a right triangle right there. Very tall, skinny right triangle, but a right triangle nonetheless. And what's nice is I can count those distances. I can see that this horizontal piece of the triangle is just 1. I can see this vertical side is 9. And so really, since I have 2 sides of the right triangle, I should be able to do the Pythagorean theorem to find that third side, which is my hypotenuse. So 1 squared plus 9 squared is equal to r squared. Again, you don't need to use the picture. Some people just like to use the distance formula, whatever works for you. I like to use the picture. And so I'll go ahead and solve this equation. Remember, these values, I guess, should technically be in parentheses, especially if they were negative. That would be important. So I've got 1 is 1 squared, obviously. 9 squared is 81, is equal to r squared. If I add those together, I find out that r squared is equal to 81. And so at this point, we want to be clever, because I could go ahead and take a square root like we're used to doing and find out what the radius of the circle is. But they don't actually ask me for the radius of the circle. They just ask me to write an equation of the circle. And recall that that blank in my equation represents the radius squared. And so the number I want to use to plug in there is 82. If I found the square root of 82 and either simplified that radical or got a decimal, I could find out what the radius of the circle actually is. But this time I'm not asked to do it. I'm just asked to find the equation. And there is our equation.